for all of our scenarios, then all objects will fall at exactly the same speed, irregardless of their mass, their size, what, they will fall at the same speed or with the same acceleration. Yes, Ronnie?
When they take the air out, the building must fall into itself.
Now, so what he says in there is they do leave a bit of air, but not enough to have an influence on the experiment. Yes.
But if they take out all the air, the whole building will crumble.
No, it won't. It depends on the suction force, and it depends on a lot of different things. It's not just like sucking in like a plastic bag and it crumbles like that.
It's not compact.
Yes. All right. What did I want to say here? All right. So what we are going to do is we are going to prove now that this G, this gravitational acceleration, is independent. Independent. It means it doesn't matter of the mass of the object. So it only depends on something else. All right. Now this proof, you do not need to know for a test and exam. The outcome of the proof you must be able to apply, but the proof you do not need to be able to show. Okay, so if you remember, we have this formula. Fg is m times g. Yes? You know this one. Fg stands for the weight of the object, or it stands for the force that the earth exerts on the object. Okay, the gravitational force. So it's the force between the earth and the object. Yes? So this mass here is the mass of the object. And this G is 9,8 on Earth. Nothing new there for you.
Why is it 9,8?
That is with a lot of experiments what gravitational acceleration is. So it's not a made up number, it's what it actually in real life is. Alright, then according to Newton's gravitational law, we have F is G m1 m2 over r squared. That's what we did yesterday. Yes? Any two objects in the universe will attract each other with a force. Now, if these any two objects is, let's say, an object and the earth. So the force between an object, you, and the earth. You attract each other with a force. Then it's basically you, object, and the gravitational force that the earth exerts on you. Yes? So if we assume, if we take here the first M to be you and the second M to be the earth, then it's the same as the gravitational force of the earth on you. Yes? Okay, so I'm just going to rewrite this formula as G M big M over R squared. Where I'm going to say that the object is small m and the earth is big M. So just so that I don't have M1, M2. Right, so we just said if we assume it's between you and the earth, then this F is the same as this F. Because what is Fg? It's the force that the earth exerts on you. The force that the earth exerts on you. So then instead of writing F, I can write M times G. Okay, then if you look at this formula, you see here's a small m, u. Here's a small m, u. If you are on both sides of the equation, then you can cancel that out, right? Mathematically. So we can cancel that and that, so that you get G is equal to capital G, capital M over R squared. And this is what we wanted to prove. We wanted to prove that G, this 9.8, this gravitational acceleration, is dependent on the mass of the Earth and the radius of the Earth. That's all. It has nothing to do with you. Because if you have your calculator or you have a bottle of water or you have you still fall at 9.8 meters per second squared, like we just seen in the video. Yes. Then bigger meaning mass or meaning a radius? Then it will be less. Because from here we can see that G is directly proportional to the mass, meaning the bigger the mass, the bigger the gravitational acceleration. Why? Because it's at the top of the fraction. And from here we can see that G is inversely proportional to the radius squared, or the distance between them. So the bigger the radius, the smaller the gravitational force, because they are further away from each other, like a long distance relationship. But if an object is bigger, then the mass is also bigger. So that's what will be like a grey area, what you're actually asking. Okay, so from here, you can see that G is only determined by the mass of the Earth or the planet or the moon or whatever you're standing on, and the distance from the center. Then it is a vector quantity, so it has magnitude and direction, size and direction. Then, very important, G is not constant. We, on the surface of the Earth, take it to be 9.8 meters per second squared, but as soon as you go to the moon or you go to another planet, then it's actually not 9.8 anymore. Then it changes, depending on the mass and the radius of the planet. Okay, so it changes from place to place, and like I just explained, if the radius is bigger, then the gravitational acceleration becomes smaller. So they are inversely proportional to one another. I'll be with you in a moment. Now this formula here is a formula that you need to know that is not on your data sheet. So it's one of the formulas that you must go memorize, not on your data sheet. You can get it from this one. This one is on your data sheet, and this one is on your data sheet. Okay, so if you forgot it, you can put these two equal to one another again and get this one, or you can just go memorize this. Right, yes?
And what is the mass of the Earth?
Alright, we're going to get to that in a moment. Yes.
Can we write like a small in a big?
Yes. Alright, so what I want us to do, please, is open your writing book and please go to question page 25. Let's see how we are going to use these formulas that we've learned the past 2 days. Okay. So you, in your writing book, you write page 25, question 5. Today is the 28th of February. Tomorrow is what day?
29.
And what is special about the 29th?
It's an extra day.
It's an extra day. Every 4 years we get the 29th of February. You don't get it every year.
There's no school.
What do you call it in English? Afrikaans, the skrikkeljaar. A leap year. So tomorrow is a
Why is it a leap year?
leap year. It just means that you have an extra day every 4th year. No, you can make the day fun for yourself. You must pray every day.
When we separate,
you don't have a special day. It's a special day.
when we separate, how is it special?
Day.
It's separated.
Huh?
It's not like a straight day. Like we separate like in hours, on days.
Okay, Claudia.
For question.
All right. So we have the Earth, and then they say there we have a satellite, and the satellite has a mass of 350 kilograms, and it is a certain distance from the center of the Earth. They say it moves at a speed v, and then they say The Earth exerts a gravitational force. So they say the gravitational force that the Earth exerts on the satellite is 175 newtons. Okay, now they ask at question 5.1. Write Newton's universal gravitational law in words. Really? Go for it.
Each body in the universe attracts every other body on. Each body in the universe attracts every other body with a force directly proportional to the product of the masses and inversely proportional to the square of the distance between the centers.
Yup. That was fun. Okay, so she definitely has another 2 marks in her pocket for the test of Tuesday. Ne? Tuesday, you write your first. Is there another Tuesday in this week? The 5th of March, Tuesday, you write physical sciences. 2 hours, 100 marks. I said this at the beginning. You write on vectors, you write on Newton's laws, you write on electrostatics. Yes. 100 marks, 2 hours. 1 paper. Alright. And have I given you that booklet with the past papers in? Yes. Like you did last year. You're going to use that to study from. Alright. 5.2 it says. Brian says. Now I only have the Afrikaans in front of me. 28. Tomorrow is the 29th. It says there. Brian argues that the Earth exerts a stronger force on the satellite. So focus now while you read. It says, Brian says the Earth exerts a stronger force on the satellite compared to the satellite on the Earth. Okay, that's what Brian says. Because the Earth has the larger mass. Name and state the law words that you can use to clarify Brian's misconception. So they'll really tell you Brian is wrong. That's not true. Which law tells us that Brian is wrong? Let us believe. So it says the Earth on the satellite is bigger than the satellite on the Earth. Second law. Second law has to do with mass, acceleration, and force. Are we speaking about mass and acceleration? No, the universal gravitational law we just did, so it will be silly to name and say Newton's third law. Okay, so you're going to say Newton's third law, and Retabile, please state Newton's third law. I'm going to give you the formulas.
When object A exerts a force on object B, and then object B is simultaneously to object A, they're equal in size but have that in opposite direction.
Well, you just missed the word. Then B exerts a force on A. Well done. Okay, so because A is Earth, B is satellite. So if Earth exerts a force on satellite, then satellite exerts the same size force on Earth, just in opposite direction. Alright. Then 5.3 they ask, calculate the height of the satellite above the surface of the Earth. So what are they asking? They want to know that there. What is the height of the satellite above the surface of the Earth? So they want distance. They want meters. Okay, now they've already given us a clue what formula to use, because they say state that definition, that's your clue. You're going to have to use that equation. Okay, so let's quickly look at it. We have F is equal to G M1 M2 over R squared. Info table. Nicolo, what is the force? What is that F? Because that's not what they're asking. They're asking height. So we must have force. What is the force? What do we measure force in? And you can only ask Bukamuso. Say again? Newtons. So they give us that newtons. 175. Okay, the next one, G, there is a constant that you will find on your data sheet. The first mass there, we have the mass of the satellite is given. What must the second mass be, Hope? Because that is the force between the satellite and the Earth. There is the mass of the satellite. What must that second mass be? The mass of what? Say again? Not the size of what? No, that is the mass of the satellite. Huh? The mass of the speed. That does not make sense. The Earth. That is the force between the satellite and Earth. So the one object is the satellite, the other one is the Earth. Now you read the question, you see, but they didn't give me the mass of the Earth. Go to your data sheet, please. On page 23. On page 23, you will see there in your info table. Go with it through with it with you. They give you there gravitational acceleration 9.8. They give you gravitational constant capital G 6.67. They give you the radius of the Earth. They give you Coulomb's constant, which we didn't express. They give you the speed of light. They give you the charge of an electron. They give you the mass of the electron, and then they give you the mass of the Earth. That is given to you. So they don't have to state it in the question. You can just use it.
How did they completely miss?
With a lot of experiments. But it's not complete. It's like 5,98 blah 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 blah. We just run it.
So what did they do to calculate the
I have no idea. I have no idea.
It was beta.
Say again?
It was beta.
Okay. 5.98 times 10 to the power 24. So that is given to you. You do not have to go calculate that. Okay. So what the question was, what is the height above the Earth? Height is measured in meters. What is radius or R? This is measured in meters. So we are going to go calculate R. Okay. So we have the 175. Okay, so Courtney is going to calculate it for us. And remember, this R is below the fraction. We don't want it, so we take it up. We take that down there, and we square root the whole thing to get rid of the square. Do you trust Courtney?
No.
You get 7. I get 2. Right? Do you put the square root in a wrong place? Okay, and you get?
2.8244 times 10 to the power 7.
Okay, and that is measured in meters. But what did you just calculate? Okay, is there anyone that struggles with that? Anyone that I must come assist? No, not square. Grade 11th. You want the square root at the r squared at the top, right? So we take that this way, and then we have 6.67 blah 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 over 175. Yes? Not done yet. Now you want to get rid of the square. What must you do? You must square root this whole thing. Yes? Okay, anyone still having a problem? Remember, it's now your time to ask. Sharp? Did you put your calculator in scientific notation? Shift, setup, 7, 5. Yes.
What is a number that has, what do we call a number that has 22 zeros?
20. Oh, I have no idea. No idea. Okay. Are you sharp? What's wrong?
I get that answer, but not. I get like 200
Shift, setup, 7, 5. Shift. Don't delete your answer. Shift, setup, 7, 5. Scientific notation.
Someone asked a question yesterday regarding the sun and not the earth.
Yes?
Did you find the answer?
No. Did you?
I forgot. I was
Because I'm going to Google. You can also just Google.
I just remembered now.
No, I did not. All right. Now, we're not done with the question yet. The question was, what is the distance of the satellite from the surface of the Earth? What did we calculate here? According to the law, it says the force is inversely proportional to the distance between their centers. So what we got is this distance. The question is, what is this distance? Okay, so what we can do is we're going to say, oh, it's not half. You don't know it's half. What we can do is we're going to say, okay, we just calculated that distance. You have on your info table, what is the radius of the Earth? I just went through it with you. So we have this distance. We just calculated it. If we delete or subtract that distance, then I get what the question is, that distance. Are you with me? Yes? Okay, so go. Is your data sheet still open? Go to your data sheet. Okay, so you're going to say the height is this 2.8244 times 10 to the power 7. What is the radius of the Earth? Is 0.38 to the power 6. Okay, so when you subtract that, Khali, what do you get? Yes, Mual. No, not what is the answer, what is your question? How many questions have Muhao asked today?
Two.
10 mil.
Like 3 questions.
I think we're at 3. Who's counting? Are you counting? How many does he get? He gets 3. So you're done for the day.
No, 5.
Oh.
Did I say 5? We have 2 left.
He only has like 4 left.
It's 6.
4 left.
Khali? And if you round off, 2.1? 9 times 10 to the power 7, and the unit, Khali? Meters. Right, so this is why the question counts 5 marks, is because it's formula, substitution, answer, subtracting, answer. Sharp. Alright. Yes?
You don't get marks for doing the different.
No, you never get that. Alright. Let's look at question 6. So just on the same page, question 6. It says there, the sun exerts a gravitational force on the earth. So the sun pulls the earth. 6.1. Write down Newton's universal gravitational law in words. Start to go for it. I'm going to write the formula. You go for it.
Each body in the universe
Okay, we'll attract another body with,
a force
that is,
directly proportional to the mass
what of the mass? Of the masses.
of the order to the masses and inversely proportional to the distance opposite between
The what?
the centers squared.
Squared. Right? Right, 6.2, they ask. The mass of the sun is 330,000 times bigger than the mass of the earth. So if the mass of the earth is x, then the mass of the sun is 330,000 times x. Okay, so that is what they're basically saying. It is not 330,000 kilograms. It's so much bigger than the mass of the earth.
How do they know?
They are saying around about. Okay. Yeah? Okay. They say calculate the size of the gravitational force, so they want the force of the sun on the earth if you can assume that the distance between their centers is 150 times 10 to the power 6, and then important, they say kilometers ish. So do we work in kilometers? No, we work in meters. How do you go from kilometers to meters? To the power of? No. Think, if I tell you, you walk to school 1 kilometer, how many meters do you walk to school? Say again? 100 meters. So there, the 100 meters there. You work very fast. No, you don't divide. Of? -3. -3 means divide. Not -3, +3. So that basically gives you 150 times 10 to the power of 9. 6 plus 3 gives you 9. Yes? Alright, so that's not too difficult. We're going to use this formula. They want the force. G is a constant that you will find on your data sheet. Ooh, but now, I have the masses as x and 330,000 x. What is x? The mass of the Earth. Where will I find that? Thank you very much. Data sheet. Which is 5.98. Am I right? Times 10 to the power 24. And then M2 is 330,000 times 5.98 times 10 to the power 24. I don't have enough space there. Okay, make sure you understand why I wrote that down. Ntando, something is missing with what I've written down. Thank you. Mo, how is our deal still on?
Huh?
Our deal still on?
Yes, ma'am. This is the stage.
3 people.
Let's make it 2 people now.
Alrighty. Did you check the people that's in your class, Mo?
Ma'am, it's not that I trust them, it's just that I know they don't want to fail, so I trust them.
A lot of people don't want to fail, but they still do. It's true. Ona, you on it? Are you guys checking Ona?
I get 3.4. Should I round it off? 3.5 times 10 to the power 22.
And the unit?
Newton.
Okay, now they say calculate the size, so that's why you do not have to give a direction. Okay. Now they ask 6.3. So what did we calculate at the top? That which you've calculated is the force that the sun exerts on the earth. The sun on the earth. Okay, now the answer is 6.3. How does the size of the force that the earth exerts on the sun compare to that previous one? How does this compare to that? That is what they ask. Now they say, right, greater than, smaller than, or equal to, and say which one of Newton's laws do you or did you apply to get to that answer? Sebabaso? No, and you can only call Retabile. Incoming call. You are declining. Why do I ask you? Because you got the same question in the previous. So what was your answer? It was Newton's third law. What does Newton's third law says? If A exerts on B, then B exerts on A. Exactly the same force. Okay? So how does it compare? It is equal to. And whose law did you look at? You look at Newton's third law. So I've told you, Newton's third law is going to be a concept question. So it's not going to be a calculation. It's going to be how does it compare the two forces with one another. And I told you when we discussed it, I said you're going to look at do these two things crisscross with one another. Okay. Then question 6.4. They say the moon has a radius of not a radius. What do they say in English? Sorry? Diameter of 3474 times 10 to the power 3 meters. And the mass of the moon is 7.35 times 10 to the power 22 kilograms. Right. Now they ask, calculate and read carefully here. What is the gravitational acceleration? Not gravitational force, gravitational acceleration, G, on the surface of the moon. They want G. Alright. Now the only formula, or only two formulas that you have, is Fg is equal to m times g. But do you have Fg here? Did they give that to you? No. So you can't use this formula. And the other formulas on your data sheet is this one. But that does not have g in it. So what formula are you going to use? That other one that we just did earlier today that I told you is not on your data sheet. The small g is equal to capital G, capital M over R squared. Not on your data sheet. Now this capital M here is the mass of the planet or the moon or the big thing. Not mass of rock or mass of tree or mass of person. And the mass of the bigger thing, like the moon. Alright, so if we substitute that in there, we have 6.67 times 10 to the power negative 11. Mass of the moon, they gave that to us. Oopsie. Ooh, what do we need there with R? It's the radius, it's from the middle point, the distance between centers. So it's not the diameter. Diameter is from one side to the next. Divide by 2. So you're going to say a half. Divide by 2 is the same as multiplying with a half. Ne? Times 3474 times 10 to the power 3. Sarah, are you happy with what I've written down? You need to square this thing here. Say again? The whole thing you need to square. Do you guys trust Noel?
No, why not?
Because their life depends on it.
I'm a trustworthy guy, maybe we should
Don't back away just yet. Here's Noel.
1.624.
That's all, ne? And the unit for gravitational acceleration? Mooi.
You don't write times 10 to the power 0.
No, because that's the same as 1. Alright, grade. Thank you very much. Grade 11. Your homework, your little bit of homework. This was question 6.4.1. I want you to do 6.4.2 for homework. Alright, then so tomorrow we're going to complete that. I'm going to quickly do one calculation in your notes still, and then we're going to go on with electrostatics, okay, that we started with in extra classes. So please bring those notes with as well, electrostatics, finishing Newtons and electrostatics.